There is nothing else we could do with the problem. Yes, you're still testing all those other problems, but the thing is with the book, if they gave it to you and they didn't work, why give you the problem? You wouldn't have anything to do. So they ask you these always separately. So again, we pull out the P, we pull out the Q, we pull out the N. Yes, this is binomial. They say yes, they go to work when they're sick. No, they don't go to work when they're sick. We test. If the test passes, we find the mean, we find the standard deviation. Generally, the mean is one more than the x values, and these are always discrete values. So you should at least get one decimal unless it terminates. The standard deviation, I usually go the same as the mean, but because this had no decimals, you can go out a decimal, 2 decimals. As long as your rounding is good. I tend to be more of a decimal person than not. Okay. These guys had basic information. We found that 67% opposed Medicare eligibility from 65 to 67. You randomly selected 80. Remember, you're talking about a population here. There's no samples. You're asking 80 people from the population of all U.S. adults. And you ask them how they feel about raising eligibility from 65 to 67. The probability that the number who opposed is I gave you, there's a whole bunch of them, for at least 65. So again, first thing you got to do is this over here. We're going to pull out this information. This says, yes, this is binomial. Then we're going to check, does this binomial approximate a normal curve? If it passes, yes, we continue. The nice part about the n times p, once you checked it, you just found your mean. Now, one thing that's good to do with this, if you just headed to the z-score formula and you said, okay, pull out my z-score, you get to this problem and you say, wait, what is the mean? What is the standard deviation? The only time we don't have a mean and standard deviation is this binomial one, where we have to find the mean ourselves. So when you're looking for the mean and the standard deviation and there is none, it's probably a binomial one. The only other time we do it is we mess with your standard deviation for a sample, but we still are always given a mean, right? We're always given a mean. So the binomial one, we found the mean, we found the standard deviation. Again, go 1 decimal point if you can. Plug this in. Now the correction for continuity is important. At least 65, start like this. Lay out your numbers. Can you use 65? Yes. So drop this guy left end, 0.5. This is the statement you should be using when you make your z-scores. If you forgot the correction for continuity, you forgot a very important part. This gives us just a little bit more space under our curve. Because it took the end of 64, let's say this was 64, it took the end and just expanded it a little bit. So we plug it in. All our rules apply. Here it is to the right. Our rules apply. It's got to be a small area, so this is what I'm talking about. This is another reason why you sketch. You say, well, it can't be that large, so I forgot to subtract it from 1. It's got to be small. If the book asks you if it's unusual, their cutoff is 5%. 5% to the left, 5% to the right. Those are unusual according to the book. So this guy is less than 1%, so this would be unusual. And people above 65 definitely want to oppose this. Well, 65 people, that's a lot of people, so you want people to oppose this. Exactly 50, the exactly 50 has a problem. If I look at exactly 50, it's one little line like this. It has no area. No area to the left, no area to the right, no area on the line. So at exactly, you have to expand down and up. You actually have to make it a bar. You have to give it a little bar so we can find the area. Again, picking an exactly number is hard. Okay? Picking a to and from number, at least at most, from here to here number is a lot easier. Find your z-scores for both. Make sure you use your corrected for continuity and subtract your areas. Again, if you like the calc or you're unsure about the calc, this one is the nicest one. When you're doing an in-between, this one, on my calc, this doesn't seem to want to cooperate today. When you're doing an in-between, this is nice because now you have your lower limit and your upper limit, and some of you get a little nervous on the lower and the upper. This is all there is to it. Even if you don't like the calc, this is the best one to use it for. You found the mean to be 53.6, and you found the standard deviation to be 4.21. As soon as you fill that in, it cuts right to the area. You don't have to find your z-scores, you don't have to find your areas, you don't have to subtract them. If nothing else, work your calculator for these instead of the formulas. It works out nicely. Someone moved my thing up there. And a more than 60, remember, start with the 60. Can you use 60? No. So the first number you can use is 61. So drop that 0.5. Will I ever hit a 60.5? No, the first number I will hit is 61, which I expected. And again, it's to the right. Make sure you subtract your area. Here's another one. I know these had a lot of work, but I wanted you to get used to doing these. 35% of U.S. workers from the population are college graduates. You randomly select 500 U.S. workers from the population, and you ask them whether they are college graduates. Don't forget, pull this out first. This tells me, is this binomial? Sure enough, it passes both of my tests. My numbers are large, so it's going to pass this test. This is my mean. Find my standard deviation. For an exactly, remember, it's one little line. So you got to give it area. Drop it 0.5, God bless you. Raise it 0.5. Find your z-scores, subtract your areas. Stop me if you're not getting this, because I don't want to bore you to death when you already have this. The hard part is usually in the statement itself. Correcting it for continuity, because the rest kind of works the same. No more than, when you're doing no more than, think money in your pocket. If you have no more than $225, can you lend your friend $226? You have no more than that. That's the most you have. So less than or equal to. So pick the high number. Can you use 225? Yes. Expand that 0.5 and set this up. Now, because you're looking to the left, yeah, now.
I know you went through with me on Friday. I'm still really not getting it. Why is it that you have to add 0.5? That just doesn't really make much sense to me.
Okay, because
if it's no more than 225, then you have 225.
Right, but we took your binomial things. So you had 224, 225, 223, all the way down. So here's my curve. Here's my, I don't remember where the numbers are. What's the mean on this, 175? So somewhere up here, here's my numbers. Here's my numbers over here. This is 223, this is 224, this is 225, this is 226, this is 227. I just went by ones, let's say. They're discrete numbers. They really don't match this curve. A discrete number says you just have this guy, you just have this guy, you just have this guy. We need to use a normal curve. So we check to make sure we can. And we agree we can. So when I have less than this, it says, okay, if you take this number and you have less than this takes care of all those bars that aren't there that you see, because this has no area in between here. I have no area in there. I just have one number. I never will get a 224.5. I will never fill this in. Remember how we used to find your z-scores for 80.2, 222.6? We used to find all the decimals. You will never be asked to find a decimal one here because they're all whole numbers. So technically, there's no area in between here. But when we do a less than, we include our whole area because we said we did pass the test. We can use your normal curve. But the key is, you still need to make a bar out of this last guy. This last guy needs a bar because he's got a little bit of extra room right there. It's just, and if it's on the other end, it needs a bar. These guys don't need a bar because they're covered by my area because I'm allowed to use a normal curve. It doesn't fit my normal curve, but because I passed those two tests, I'm able to use that where all this area will be included. Otherwise, how do I chart that area? Like the in-between is perfect. If I said exactly 226, if you looked at your normal curve, here's 226 all by itself. How do I find exactly 226? I don't know, it's one line. It doesn't take any area. Do you know what I'm saying? I'm counting whole numbers. Here's my 227. I have no 226.5. So for me to count that area of just that little entry, I have to make it a bar. It's a hard concept to catch because we're putting something that you measure with whole numbers on something that you measure with decimals. This is a continuous graph. Discrete numbers are not, they're whole numbers. So we have to make them into decimals, if that makes any sense. We have to make them a decimal. We have to give them decimal values. Nothing underneath here because I'm already covered that. Okay, here's an at most. This again is the most in your pocket, less than or equal to 200. So remember, oh, I wanted to hit this one. If you are 225 and you're less than that, right? If this is 473 and your graph only goes up to 349, you can have up to 100. You can have as far as you like on Z-scores, but your area to the left is approximately 100. You covered your curve, right? This guy, remember to correct that for continuity, and area to the left is what you look up. I'm going to hit the timer here. I know these are tough concepts to get, but kind of think of it as we want to make these guys into decimals. And that's the only way we know how. Okay. A survey of U.S. adults, we have 51% think high school students should be required to learn foreign language. These are populations. And we asked 200 from the population. First we check to see, can we do this? Yes. Can we approximate a normal curve? Yep. We find the mean, we find the standard deviation. We say at least 120, greater than or equal to. So I can start at 120, 121, so I drop that 0.5. I need to make it a decimal. Just think in terms of that. You need to make your whole numbers into decimal values. And if you're going to the right, don't forget to subtract from 1. At most tells me I'm going to the left. Okay? So at most, that's the most I can have. I'm going to raise that guy to 0.5. They're pretty much the same, right? They're pretty much working the same. Your first checking, is it a binomial? Which of course these are going to work because otherwise you wouldn't have a problem to do. And can I use my normal curve? Can I put my whole numbers on a curve that has decimals? Yep, I can. So before I can work with them, I need to make them decimal friendly. Let's think of it like that. Okay. And here's an in-between. Now, be careful with the in-between. If the between says inclusive, then I'm including those numbers. If it says between, then you're not including those numbers. So start like this. I start like this. And I say, if I'm between, can I use 80 and 120? No. So I take this guy, I drop it down. I take this guy, I raise it. And again, you have to do your Z-scores for both. You have to subtract your areas and give me an answer. Or better yet, use your calculator for this guy. Once you find these two pieces right here, put it in your between in your calculator. Make sure your inequality says less than, less than. A number line reads left to right. Some of that Common Core stuff has greater than greater than. I totally disagree with that. Hang on, guys. How many do we have left here? One left. Again, 5%. 5% is small, but your N was large. So company A has less than 250 employees. It's just changing your N on this one. So they just were kind of trying to show you like what would happen to your probabilities. You had to redo each part with this. You had to redo your mean. You had to redo your standard deviation for each part. So look what happens to your standard deviation when you go from 250 to 500. Your mean got a little larger. Normally your mean didn't change before, but these are different. These are binomials. So my standard deviation a little bit spread apart. Your statements are the same. Was that all there was to this one? And company C. And company C also. And why is that standard deviation getting larger? We're not dividing, we're multiplying. Standard deviation used to get smaller when we divided by larger numbers, but these are not dividing, you're multiplying. So not only is the mean getting bigger, but the standard deviation is getting larger. But the rest works the same. I have a question on this. It might even be a little while for you to remember since Friday. Okay, tomorrow what we're going to do is do a review in class. Wednesday, I do see you, so we should be good with that.
So we're only having the quiz on